Another example with inclusion-exclusion might deal with the kinds of equations we've talked about before with integer solutions. This one here is the equation x1 plus x2 plus x3 plus x4 equals 25. But I'm going to count those non-negative integer solutions that have x1, x2, and x4 all less than specified numbers there. Now, because of the way we use stars and bars, it's easy to allocate stars to say that one of these values would be at least a certain amount. But this is the opposite. And so what I want to do is take the total solutions. We'll take the total minus the ones we don't want, minus those with one or that's an or more of x1 greater than or equal to 7. That's the complement of this one. x2 greater than or equal to 5, or x4 greater than or equal to 8, the complement of each of those. One or more of. So this is an or, and so we're going to have to count how many ways we can get this with this big fancy or in there. So I'm going to say let's let A be the set of solutions with x1 greater than or equal to 7. B will be the set of solutions with x2 greater than or equal to 5. And C will be the set of solutions with x4 greater than or equal to 8. This is parentheses here. There's the 8 right there. So I want to count how many solutions have one or more of those bad features, like so. And that we know is a sum of the things in each of the sets individually, minus the the number in each pair. This should be B plus C, B intersect C, I mean, plus the number in the intersection of all three of those collections. So let's go ahead and count these, and I think I have enough room to do all these in here. So I'm going to start writing these down. So the number of things in A, the number of solutions, as we go back up here, the number of solutions with x1 greater than or equal to 7 dedicates 7 stars. So we'll set aside 7 stars for x1. And so that means we'll have 25 stars minus 7 is equal to 18 stars. And how many bars we have? 4 categories. R is 4. So we need 3 bars. 4 minus 1 bars. So we have 4 minus 1 bars and 18 stars. So this is 18 plus 4 minus 1. Choose 4 minus 1, or 21, choose 3. B is similar, except now we're setting aside 5 stars. So we'll have the set aside will be 25 minus 5, or 20, but we still have 3 bars. So for simplicity, I'm not going to write 4 minus 1 every time. I'll just write 3. So this is 20. Okay, I'm subtracting 5. Yeah, plus 3. Choose 3. So 23, choose 3. For C, we'll set aside 8. So that means we're going to take 25 minus 8. So that's 17, and we'll still have 3 bars. So I'm going to stick with the green here and say we have 17 plus 3, choose 3, or 20, choose 3. So we have these 3 numbers, and those are the ones we're going to add, right? We'll add those 3. So those are all pluses there. Let me go ahead and make a mark on that. These are all pluses. Yep. Okay. Now let's do the 2 of them at a time. So let me scroll up here, and we'll do intersect, whoops, go back to the green. A and B means that we'll be dedicating, if you can look above here, we're going to dedicate 7 and 5, so we're dedicating 12. So set aside 7 plus 5 equals 12 to set aside. So that leaves 25 minus 12, or 13. 13 stars that we're going to distribute after we've set those aside. So this will be, go back to the green here, that'll be 13 plus 3, choose 3, or 16, choose 3. A intersects C, we'll set aside 7 plus 5, or 8, so 15. So 7 plus 8 equals 15. 25 minus 15 equals 10. So we'll have 10 plus 3, choose 3. So 13 spots, stars and bars, and then 3 spots for the bars. So that gives us 13, choose 3. And then B intersects C. So for B intersects C, we are setting aside 5 and 8 is 13. 25 minus 13. 25 minus 13 leaves 12. So that will give us 12 plus 3 over 3 is equal to 15, choose 3. So those are all of the sets 3 at a time, intersection of 3 at a time, where we're employing or imposing 2 of these conditions at once. Okay, and there's 3 ways to do that. So these ones right here then account for the double count, and so we're going to take those out. But of course the ones in all 3 sets we've taken out 3 times and added in 3 times, and so now we've got to take A, B, C and look at how many solutions satisfy all 3 of these conditions above. And so that would be setting aside 7 plus 5 plus 8, or 20 set aside, so leaves 5 stars and 3 bars. So that'd be 5 plus 3, choose 3, or 8, choose 3. Yeah, and those, recall, get added back in. Those get added back in. So in the inclusion exclusion, so the number of solutions to remove is A union B union C, combining all the sets, the number in there, and we'll add these and get 21, choose 3, plus up here now 23, choose 3, plus 20, choose 3, minus 16, choose 3. I'll put a bracket here and add these. 13, choose 3, plus 15, choose 3, and then plus 8, choose 3. So that's how many to remove. Those are the ones that are bad. And so our final result, and I'll try to squeeze it in on this next slide a little bit, is as follows. So the number with x1 less than 7, x2 less than 5, and x4 less than 8 is the total, which is 25 plus 3, choose 3, minus this computation above, minus 21, choose 3, put a bracket here, plus 23, choose 3, plus 20, choose 3. And then I'll put the minuses here, minus 16, choose 3, minus 13, choose 3, minus 15, choose 3, plus 8, choose 3. And I'm not going to try to calculate that. The point here is to illustrate how inclusion-exclusion works, and do it in the context of an interesting example, one that uses stars and bars at the same time.